All right, happy Monday. We're moving on to new stuff. Very exciting. All up books here. Don't forget your chapter 4, right? It's due today, 11:59 p.m. We're going to start talking about functions here. Uh, Functions are great. They don't actually let us do anything new, though. It's a little bit sad. So it allows us to write neater code, right? Write more efficient code, uh, and they're helpful, and we're going to see them all the time. Because in general, our good rule of thumb is anytime we have the same code twice, we should feel bad about ourselves. So functions allows us to not have duplicate code. We'll take a look at how that looks here as we go. So we'll have 2 weeks for this chapter, so they won't be due until the 13th here. So let me go plug that in so that you have the date there. Chapter 5. 13th. And that is a no submission. There we go. Make sure I did that one right. All right, so I'll run the chapter 4 report. I'll probably just do it Wednesday when I'm here, uh, maybe Tuesday, but sometime after tonight, we'll run chapter 4, and not doing great on those numbers here. We definitely did better the first couple chapters. So that's what it is. Um, yeah, if there's anything I can help with these, let me know. I'm happy to talk and chat. Um, they're usually relatively straightforward. It's going to take some time, energy, and effort. And looks like one person's got ahead on chapter 5. Awesome, maybe. So we're working through chapter 5 here. So let me pull up Visual Studio. I'm gonna make a new project. Is this week 6 now? Is this where we're starting? Because if you want to count the first day as a week, that's probably close. 6 functions. I don't know. Part 1. We'll call it part 1. So we have lots of time for functions. All right, and remove some of this stuff. So int main here is actually a function. So we've been using this function a whole lot here. We just didn't really do anything with it ourselves, didn't really call it out as a function here. We've been using other functions as well. When we did some number rounded up, like 3.5 rounded up is, we did the ceil function, right? That was rounding up here. So we take 3.5, we can round up. Very exciting. Probably want a space here, right? So that separates a little bit. So these are functions here. It calls some code. Some functions you hand things, sometimes you don't. So most of the ones we've been doing, we're handing it something here. So we're giving it, here's the 3.5, and we're expecting back some kind of result, right? So we can make our own functions here. Now, C++ is a little bit particular about functions here. So we're going to make ours above main most of the time. We'll get into other times when we don't need to, but most of the time we'll put them above main here so they're easy to find. And if we want a function that gives something back, the first thing we have to tell C++ is what we're giving back. So in this case, main is giving back an integer. We can give back an int, so we can say, hey, some number, and then a set of parentheses. In this set of parentheses is the list of anything that we want to be given to our function. They're known as arguments or parameters. Technically, this is the argument here. Inside the function, it's a parameter, but it's not very exciting. And we use a return keyword to say, give something back here when we're done. So in this case, we're just giving back the number 10. It's not a very interesting function here, but we can do that, and we can use it outside of that function here. So I can output some number is, and I can call some number by name, right? So I'm putting a name to that bit of code that I just wrote. It's not exciting code. We'll get to more interesting functions in a minute here. And if I put it in debug mode, right, you come over to this left side, add a little red dot, that's our breakpoint here, and we run with debugging, it'll pause there, and now we can actually bounce around. So before it's been kind of top to bottom, and then we said, oh, now you can do branches, so maybe this part runs or this part runs, or maybe we can do loops where you just go back to the top, but it's still pretty much top to bottom. So finally with functions now, we can go completely somewhere else. So when I get to my point here, it says some number is what? Now I've got my couple options here. I have a step over. Now step over is not going to go into our function because we want to step into. That's the other option here. This is F11 if you like your keyboard shortcuts. I want to step into that function call. And step into says, okay, sure, I'll go up here. You called some number. I think it's not a very interesting function, but we can see on this call stack over here, we came from line 15. We're running some number. We're currently at line 8. When this is done, come back to line 15. Right? It has to remember where we were. So for this code to run and come back. So in this case, it just returns. We get back a 10, and we print out our output here. Very exciting. And that one's done. So we wrote a function here. So maybe we'd want some sort of function that could give us a random number. Right? That'd be much more interesting. So some random number here. Oops, so I need to set a parentheses. And then a set of curly braces. So everything inside the curly braces belongs to that function here. So if we want a random number, we can take random, right, which is a function call. Right? Remember these parentheses? We're doing a function call. And if we do like, I don't know, mod 100 plus 1, we should be able to get a number 100, 1 to 100, right? And if we want, we probably should seed that. So we have to let it include C time. I think we did it like that, right? And then we set srand time of 0 or something. That sounds right. I think I Googled it last time, but that one seems probably close enough, so we'll get a random number. So we can get random numbers now, right? So some random number is, and we'll take our some random number with parentheses, right? Because we need to call the function. The parentheses mean please call the function here. And we should get out a random number. Oh, I don't need the breakpoint here. We don't need it to pause. Oops. It has to return a value. So we said, hey, this is supposed to return an int, and we got an error saying it doesn't return a value. It needs to return a value here. Right? So we need to add that return keyword. Now it'll be a little happier here. I got my return keyword. They don't have to be one line. We can have this happen on multiple lines, but for now it's just do single lines. Oh goodness, I have to update Visual Studio. We got 74. If we run it again, we should get 84 and a different number and a different number. Very exciting. But what if we wanted to be able to give it, hey, here's the maximum number we want? Right? Wouldn't that be a helpful function? Yeah, that's good thinking. So maybe we can say, hey, in my list of parameters here, you have to give me an int for the max number. Now, what this means is inside the function, I now have access to some variable called max number. I know it's an integer. That's all I know. Right? It's probably a positive number. Might not be, but it's probably positive, right? So I can modulus by max number here, and then add 1. So if they give me 100, I'll do random number modulus 100 plus 1. Life is good. So we can now pass in, say 100 here, right? So I'm sorry, this was red here before, saying too few arguments in function call. Now that my function requires an argument here, you have to give it one. You can't call a function without passing it something that it wants. So in our case, we can pass it the 100, and we'll get a random number 1 to 100. Life is good. Now, if we do something silly like a negative number, still worked. Interesting. We got a result here. Never actually tried to modulus by a negative number. Maybe it just works. I guess it's still a remainder. Not really sure. But we can pass it a number. So this is our argument. And you can have more than one, right? If you wanted to have a minimum number and a maximum number, we could do that, right? That's just arithmetic. It's not too hard to figure out, right? Instead of just adding 1, you add a different value, those sorts of things. So you can pass more than one value if you want here. So if we wanted a function, let's do a different one here though. Let's do a function that doesn't return something. So if you don't want to return a value, you just want to run some code here, you say this is void. So void means you don't return something. That's our fancy keyword for that here. This will say, I don't know, a print, let's do a print triangle. right? Because we like our printing triangles. And maybe give it an int for a size. And then maybe we want a second argument. So if you want more than one argument passed in, you comma separate here. You say, hey, I want a char for the character. So you tell me what size and what character. And then I can print out a nice little triangle for you. So we can say for int row is, I don't know, 1, row is less than or equal to size, row plus plus, and then another loop, right? We got to do more loops for column is 1, column is less than or equal to row, column plus plus. Oh, sorry, not for int column. There we go. That would help. We can see out the character, maybe. After the column is done, then we can see out an end line. And that should print out a little triangle of any given size of any given character. Right. So we can make our own triangles here. Now this one I don't need to call cout because it's doing the printing here, right? In these cases, because I was returning an integer, if I wanted to see that integer, I had to output it, right? So it's called print triangle. Let's do, I don't know, 10. And what character should we use? Star. All right, classic. So we need to say print triangle, size 10, here's the star character. And we comma separate the values we're giving it for its arguments. So these are arguments, these are parameters for what it's worth. Almost no one cares, but technically they're different here. Uh, so this is fun, and then we can even make this be based on what the user says, right? We can ask the user how large of a triangle, and then we can get a int for size, and cin on size. Now what's fun is I have a size here, and I have a size variable here. But remember, anytime you declare a variable, its scope is what set of curly braces you declared it. So this size only exists within the main scope. This size exists within the function scope, the print triangle. So it's okay that they're both named size. They don't have to be both named size, but they can be. And then we can ask what character, use, okay, character, cin on the character, and we can pass that character as well. So I can make lots of different shaped triangles here. What size? 5? And what character? Plus. All right. Look at that. We have a fun little triangle now. Very exciting. Now, so far, nothing we've done here reduced any code. Right? We only used these things once, so we could have just put that exact same code in here. That's fine. That's okay. Right? One of the nice things we get to do is we get to put a name to what our code is doing. Right? One of the big benefits of functions is you just name what's happening. Right? So instead of having to have all of that print triangle code right there, I can just break it off and separate it into a smaller piece. One of my favorite terms is functional decomposition. It takes a big problem and you break it down into smaller and smaller and smaller pieces. Right? We're decomposing a big problem into smaller problems. Right? So I would encourage you for project 1 to use functions. You don't have to. There's nothing wrong if you don't here, but it's easy to tackle one little piece at a time here with functions. Right? Here's one small piece, here's one small piece, here's one small piece, right? It's much easier to solve a small problem than it is to solve a big problem. Right? So if we can think about our big problem and break it down into lots of small problems, you'll be much more likely to be successful solving 15 small problems than you are solving one big problem. Right? And we can solve them all one piece at a time. Talk about all the functional decomposition. Go drop that at a party you're at. Make people look at you like you're a nerd. It's okay. You're in a computer science class. You probably are a nerd. You can own that here. But it lets us break down those problems in a way that's easier to manage, easier to tackle, and easy for us to design solutions to. Right? That's the hard part of programming. Not making the computer understand what we're trying to tell it to do. It's how do we take a big problem and solve it. Big problems are hard, so we have to break them down into these small problems that we can get a solution for, right? So something like a quadratic equation. Remember, and finding intercepts, isn't that very exciting? We can find intercepts. Now, I'm going to make this be void here. We're just going to print what the intercepts are. That's not great here. Maybe we should return some values. Problem is, you only really get to return one value here. Okay, so we're going to look at some silly things to do with this here. So when I pass in size here, if I wanted to change size, I can say size, I don't know, plus 10. We're going to make triangles really big here. This will change size in my function here, but the size that I give it, when I see out on size here, is not going to change. C++ does some funny things. So if we make that size 5 triangle here, size is still 5 outside of the function. So this size, when we pass it here, we're passing by value. So I passed the value integer 5 here. So you can change this all you want up in your function. You're not going to change the original value from where I gave it to you. That's an important piece here. So if we pass things by value, you can't really change them. But what if we want them? If we want them to be changed here, we need a mechanism for that. And C++ lets us do the silly thing, which is pass by reference. So instead of saying, here's the value 5, we're going to say, here's where my value lives in memory. Here's the reference to where it lives in memory. Here, go for it. So they can either access it or they can update what's there in memory. So we can change that value here. So if we pass values in by reference, you can go and change them inside of your function. And there's a funny character we use, the ampersand sign here is for reference. I don't know who came up with it here, but we're going to use it here. So to pass by reference, we use the ampersand sign here. So now when I run size 5, plus sign here, now size is 15 when we're done. So with a single character change here, we now have access to size that we were given. And this is a little weird, yeah. So we're passing the memory reference, where the value size is in memory. So remember, anytime we have a variable, C++ is going to ask your computer, hey, I need so many bytes to store something. And your computer says, sure, here's the memory address. Here's where you can store it. So before, all we were passing was the value. So we passed a copy. Essentially, here's the value of 5. When we pass the memory address, we say, here's the actual memory address x292f78 something here where it lives in memory, so you can go and change it. So if we pass something by reference, they can go and change it. So we can essentially get more values out this way if we wanted to do some sort of silly function here. So we can have a void, I don't know, find intercepts here that takes, we need a double for, oh my goodness, I'm really tired right now. A double for B, a double for C, and then a double for intercept 1, and we want this one by reference, and a double for intercept 2. And you want that one by reference. So if you give me places to store your intercepts here, then I can go and set them. Because we're limited to only return a single value. You can return one integer or one double, one something here, but some quadratic equations have 2 intercepts. So we need a way to pass them both. Okay, so this is the form, what is this? Ax squared plus bx plus c, right? Equals 0. I think that's our default formula for this one here. Now we need to go and figure out, are we even going to have any intercepts, right? So we have to find, what is that, the determinant here to see if that's even going to be positive or not, right? That's the square root of b squared minus 4ac. So b, now what is that? We need to take power of b 2 minus 4 times a times c. That's our determinant. So that's a double determinant. Is that an ENT? Determinant? Ant? I don't even know. Double determinant. Oops. We can't even take the square root of that until we know if it's positive or not. So this number first, right? Before we even square this, if this is negative, we've got no intercepts, right? If it's 0, we've got 1 intercept, right? And if it's positive, we've got 2 intercepts, right? Thank you for being math people. I'm pulling memories way far out in my head here because it's been a while. As you can tell, I don't teach math. Okay, so if then my determinant is greater than 0, we're good to go. Oh, sorry, that's Python. If my determinant, oh man, I didn't even spell that at all close to right. Determinant, determinant, determinant? That looks a little bit closer. All right, so if that's less than 0, there's no intercepts, we can just be done here, right? Now, we might want to output some sort of message, like no intercepts found. We don't really, I don't know, don't really have a great case here for that one. Um, maybe we can give an error at some point, but that's all right. We'll come back to that. So no intercepts. If it's 0, we're okay, right? We can take the square root of 0. Formula is going to be fine, right? So if that's not the case, then now if we want to, some people really dislike having your code tabbed in and tabbed in and tabbed in and tabbed in. And the more tabs, the worse it is. It's a pretty good rule of thumb. Um, so if you don't want to have an else here and have all your code tabbed in another bit, we can just return after this. Because when a function hits the return keyword, it's done. So right here, it had a single return and a single return. So it was at the end, but you can have returns anywhere you want. And you can have more than one return, but only one of them gets to run. Right? Like our chain of if, else ifs, only one of them gets to run here. So if our determinant's less than 0, we just return. Here, you know what, maybe let's return a string. I'm going to feel better about this here. So we will return no intercepts found. That's a little bit nicer here. So we'll just tell them no intercepts were found. So we can return that as a string. Now we can go back and do the rest of the math then. Right? So then we'll have our intercept 1 is going to equal then the square root of this, oh, no, I'm sorry, negative b, right? So negative b plus square root of the determinant. We did that math already. And then both of those divided by 2a. So I have to do it before, or can I do it after? Do this one first and then divide by 2a? 2 times a. Like that? Is this good? You forgot your order of operations. You're my math guy. Right? What is dividing by 2 and then multiplying by a going to do for me? This is not dividing by 2a. This is dividing by 2 and then multiplying by a. More parentheses, right? If you want to divide by 2a, multiply 2a first. I'm really tired. All right, so that I think will probably work here for the first intercept, right? And then we'll take the intercept, the next one here, intercept 2. Then it's the same thing, but minus. Negative b minus the square root of the determinant, the whole thing divided by 2a. Right? These could be the same value, right? If the determinant's 0, sure. If they're not, it's fine. Not too big of a deal here. We'll set the two values, and then we'll return intercept set. Intercept set. Sure. So we're not actually returning the math thing that we're doing. We're just setting the values we were given here. But it should work out, right? Let's try it here. So should we ask for A, B, and C? See out. So we need a double for A, double for B, double for C. Have I shown you, some people like putting them on the same line here. You can comma separate your values here. I particularly hate the format. I don't know why. I don't like it. Some people really do. I'll leave it there because some people will do that. Then we need an intercept 1 and an intercept 2. Okay. Then we need to ask the user. Enter A, B, and C for ax squared plus bx plus c equals 0. And we can see in A, B, and C. You see in that format? I try not to do this either because it also single lining irritates me, but you can. You can get them all at once if you space separate them. So on the same input line, they can give me all three values with spaces here. It's a little awkward. I like one line at a time, but that's just my habit here. And then we can see out if we found any intercepts or not. So that is our what do we even call it? Find intercepts. Given A, B, C, intercept 1, and intercept 2. We'll get some result here, and then we can see out the intercepts here, right? Or if we found intercepts, or then it gets to be a little bit weird here. We'll try it. We'll try it. I'll put them here. Intercept 1, the intercept 1, and intercept 2. I'm just going to copy paste that and change it to 2. 2 and 2. Right? Should we try it? Oh, 5. Sure. All right. Give me A, B, and C. 2, 3, and 4. No intercepts found for 2, 3, and 4. That one didn't work very well for us, so we had to add some more new lines here too. Notice we got garbage values for the intercepts. That was kind of sad too. I think a negative C usually helps with finding intercepts. Two, 3, and minus 2. Let's try that. All right. 0.5 and negative 2. Should we try it? Do you graph those on, do you use Desmos for graphing? These are handy. Open the graphing calculator. So we said 2x squared plus 3x minus 2. It looks right. 0.5 and 2. All right, we can graph a quadratic. Look at that. All right, feeling good about our intercepts? And this whole thing relies on us passing references, passing by reference, so that we can set values here outside of what we're returning, because we can only return one thing, which makes us a little bit sad. So it's limiting to only be able to return one thing. We'll get to a way to cheat around that. We just aren't there yet. Let's see, where do we get to that here? What chapter? When we get to arrays and vectors, an array is a way of storing more than one value in a single variable. Now you can essentially return more things because you have a bunch of things in a single container, right? One container is one thing, even if it contains a bunch of other things. So you can sort of cheat around it here, but that's okay for now. So functions, printing, reasons for functions, math functions, functions with branch, functions with loops, unit testing functions is my favorite. I love unit testing functions. I don't think they give us a good, doesn't give us a good fit for it here, but that's okay. Using assert is really ugly here. I think this is terrible, but it's okay. The book really likes it. That's fine. This assert function, if it doesn't work, bad stuff happens. So you can use the assert library here. We'll go steal it here. So in general here, have you guys written English papers before? You make typos in your English papers? Is it hard to notice your typos when you're reading your own English paper? Okay, so we understand we're bad at checking our own work because we know what it's supposed to say, and when we read it, it's really easy to not notice that it doesn't say what we thought it was supposed to say, right? So as we're going through examples and testing our code, we've been running it and be like, okay, I know if I put this in, this should come out. Right? Actually, we didn't even know it was supposed to come out that first time, but in general, that would have been a good test to know here. If I have to run my code and look at it, it's possible I'm going to miss it because we're bad at that sort of thing. Right? You know what's really good at saying if this value should be out 2, is it actually a 2? Guess what's really good at checking for that sort of thing? Computers, right? We can say, hey, I put this in a function, I get back this number, and they can check it, and they can check it over and over and over and over again, and it's not going to get bored of checking it, right? Which is nice. So let's go try, and we've added our assert library here then, so we can assert after we do our intercepts. I'm going to put it up at the top here for a second here. So we can assert, we need more values here. Double A1, B1, C1, because I don't want that. Double B1. So let's set that as what, 2, 3, C, C1, we said was -2, and intercept 1, oh goodness, intercept 2, I guess, 3. I have to give them different names than what we have down below, otherwise it's going to be upset with me. Intercept, how about test intercept? There we go. Test intercept 1. And then we expect this one, we'll set the value in a minute, and then test intercept 2. Then we can go and get those values back out. So if we call my find intercepts, given A1, B1, C1, my test intercept, and my test intercept.
Your highest C.
Wow. Okay, test intercept. There we go. All right. Now we're going to assert that they match here. So the way that you do it, you say, hey, this something value equals something else here. So after we've called our function, then my test intercept should equal, what do we say, -2? Seems really weird. And then we're going to put another assert here. That my test intercept 2 equals 0.5. Now when I run my code, assertion failed. My program crashes. This is really obnoxious to have tests crash your program. That's not happy at all, so I'm going to abort because that was no good, right? Didn't equal -2. Uh-oh, what did it equal? Did it equal 0.5? Did I have them backwards? 0.5 and -2? Yeah, we did the plus first. Yeah, we could have done the positive one first. That's my bad. Then when we run it here, our program doesn't crash. Very exciting. So it's one way of testing to make sure that you get the right values out in something that's pretty critical for the values to be right. Because otherwise it doesn't run at all. Right? But we can check real quick. Oh, hey, it should give these values. Here's a quick test here. Go for it. Again, this is not a great way to do testing here. I can't really show you the better way to do testing until we get to a couple other chapters as well. There's a much better way to do testing. I can show you real quick here, which is fun. So, and making code, test our code is my favorite thing in the world. It's very exciting. I like testing. So this is Microsoft's product VS Code, their open source tool. Some of you might have used it before. You can actually write C++ code in VS Code. It just takes a couple more steps. And to get it to do all the things we're doing, again, a couple more steps. But it's a nice little environment here. It's kind of fun. It's hosted in GitHub. Microsoft owns GitHub, so they're going to use their own tool, which is fine. So this has 138,387 commits. So right, Git is tracking every time this folder changes here, and it's been changed a lot. This product's been around for a little while. So you can check out all the commits here. And then the other cool thing you get to do is if we have code that runs tests, and I'll show you how to do that. Not quite yet. We'll get there later once we have classes. When you commit your code, you can have continuous integration testing. So as your code is integrated into your source control system, in this case Git, hosted on GitHub, it can go out and run all those tests automatically for you. So in this case, hey, 34 of the 37 tests have been running. 3 of them are still running, looks like right now. This one, 28 out of the 28 tests passed here. And you can see all the different, essentially, suites of tests here that they put out here. I don't even know what most of these ones do, but that's okay. Some are interesting. Code scanning results, sure. And you can click on details. So this is another fun thing. You get features with GitHub that add on top of just tracking your source control tool. So it's saying, hey, I went and did all these things here and they all passed. And life is pretty good. I'm happy with all the automated tests that we wrote here. So again, beyond these assert ways, we can write tests that are easier to track if they passed or not here. We could try it here. It's just going to turn out really ugly. We'll try it. We'll try it and see if it works here. So in Visual Studio, there's ways to do this in Macland. I'm not familiar with them because I don't use Macs, so don't worry too much about it here. But you can Google. I think Google has a test suite or something you can use. In Visual Studio, we've made a solution with a single project so far. Right, that's about all we've done. So what we're going to do is we're going to add another project to our solution, and we're going to add a testing project. what's really cool about that is eventually when you write code that's really fun and worthwhile and useful here, rather than just throw away code for classes here, we want to give that code to somebody, right? Ideally, you want to sell it, right? Or maybe just give it away for free because you're cool like that. But ideally, in the real world, you're going to sell your code here, or the company that pays you will sell the code you write and make money off of your labor. That's how that works. But anyway, you want to not have to package up all of your testing with the code that you give away, right? Don't be like the places where you have to go download a 76 gigabyte update from Steam every time you want to play someone's game, right? That's really obnoxious, right? So you want to take away all the extra stuff here. So what we've been doing here is we've just been running our program in debug mode, but you can actually go through and uh, have a release setup here. So there's options here when you build your code to build releases versus building the stuff for debug. So again, lots of fun features we can get down the road. But for now, we're just going to add another project. So I'm going to go add a new project, and I'm going to go search here for test, and I want a native unit test project. Again, this will work in Visual Studio. It's not going to work on Mac land. I think Google testing probably works, but again, I don't own a Mac. The school hasn't paid for me to have a Mac, so I have not had a chance to try it here. Um, this is just fun features here. So I want a test project here. I'm going to call test one is probably fine here. We're going to make that. And what we get is this funny looking test build out here that does a bunch of stuff for us here. Um, but we can eventually get into writing tests here that are going to test our code in a more of an automated fashion, and we get better looking results here. So we go through, we need to go and add, oh, that's our source file, that's why. Um, this is why it's a small pane, because I want to get my source file over there. That's right, we haven't done classes yet. Okay, this will be a little harder to get to it. 1 second. Go add the linkers. All right, this is not going to be very fun. I'm sorry. There's a bunch of extra steps you have to do to get access to our code here. I'm just going to go steal this one for a second. This is not the right way to do it here. We'll get there eventually. I just want to show you because this is super fun here. We're going to write out our functions here. I think I can go put it top here. Is that going to, no, oh, shoot. Not even going to let me put it there. All right, I got too excited. I will show you later. We can cert colon r is true. Is true. I'll just put true in here. This one's a little silly. It's just saying something should be true, and I'm just giving it true. This one's definitely going to be true. And now in my test menu, I can go to my test explorer, which is a new window you haven't seen yet here, and we can go and run tests here. Run my tests. There we go, that run button. And you get a list of your tests, and if they pass or fail. And we see, hey, our test passed. Test method 1 passed. So we can write this test code to test it here, and this is what we use for continuous integration testing. More of a formal approach for testing here, but you get nice little menus for things. You don't get this ugly, hey, your program crashes because you used assert here. This whole thing because I dislike the assert library here. But having test code is fantastic. Depending on the product that you work on, again, there's a lot of variables here and lots of things that happen in the industry. If you have tests here and your suite of tests run and you feel good that you didn't break your software when you made the latest change because all of your tests passed, you can move from continuous integration testing to continuous deployment. And you can take your software and then go automatically deploy it to your servers wherever you have it hosted. So it works really well for websites. Other tools do that sort of thing. I don't know if you've noticed GitHub has asked you to update several times already. Sometimes it does it behind the scenes. It's like, hey, we need to update. Just go ahead and close. You can update your software pretty quickly. So if you have the automated suite of tests, then you can have that check and your software can say, hey, if everything passed, go ahead and deploy it. So I had some buddies I used to work with. They're over at Khan Academy now. Khan Academy updates dozens of times a day because they have continuous integration testing and continuous deployment. So the faster developers can get software changes into the hands of people who are going to use it, ideally the more productive they are. Right? If you've got this long, hey, I made a change, it's going to take 3 weeks for someone to even go try it and tell me if they like the change I made and if I did it right, we got this long feedback time, we're less effective, right? Less productive at making changes and getting them in the hands of people who can use them. So be able to close that timeline and make it faster to deploy your software is huge. So having good tests so we can get closer to continuous deployment is great. Not everyone wants your software up 3 times a day, update 5 times a day, but if it happens and no one notices, that's a pretty good thing. We can do fun stuff with it. So uh, that's the assert library. Again, I'm not fond of it. That's okay. Not too big of a deal. We did passing by reference here. We don't have vectors yet here, but you can modify strings. So if you pass a string by reference, right, we can change those. Look at some common errors. It's probably a good next starting point. If you copy paste code and you don't do it right, happens all the time. You're going to get errors here. So this is, I don't know why they don't spell things out here. This is a big pet peeve of mine. Cell to fa, Celsius to Fahrenheit. Would not have, I can't spell Fahrenheit anyway, but would not have been too hard to type all this out anyway here. So they're like, oh, I'll just copy paste it and change it here. Well, there's a problem on the right here. You can shout it out when you see the problem on the right. Yeah, they didn't change what they're returning. Good catch. So you were returning the Fahrenheit value, the fa vol, sure. Uh, and they're still returning the fa vol here. Right? So you just gotta be careful when we're doing things like that. And that's why testing our code is important, right? We want to make sure we wrote some code. Is it doing what we expected it to do for us here? So other fun things we can do with our code here. Remember, we spent a lot of time doing validation. We said, hey, is this a valid input or not here? We like doing validation loops. We can do a function for that, right? So I can say, hey, I want an integer. So get user input within range here, given an int lower bound and an int for upper bound, right? Sometimes you write a function that's useful and you're actually going to keep that same function for a long time, right? So getting something within range is helpful, right? So we can see out, enter a value between the lower bound and the upper bound, right? And then we can go, we need that's an integer for the value, and we can see in the value. And while my value is not within range, right? So if it's less than the lower bound, or my value is greater than the upper bound, we want to keep them in the loop, right? We can say cout valid, let's try again, and then our prompt again, cout cin, sure. Here's my prompt, get the value. Eventually, they should be able to get out of this loop here, maybe, depends on how stubborn they're feeling here, and we can give back a value, right? So if this works, no matter what lower and upper we give it, as long as you actually give me a lower that's less than your upper, right? If you give me a lower bound that's greater than your upper, we're going to be in for a bad time. But that's okay, right? If you can probably use it the right way. We can figure out how to check that sort of stuff later. Right? So we can go and get a bunch of values within whatever ranges we want here. Right? And we can try it out and see. Now, dealing with user input is much harder for testing, right? Because I don't know what the user is going to type in. So trying to do some sort of automated testing where we're dealing with user input, it's actually doable. It just takes a bunch more steps. So for now, we'll skip it. We can go back to how we can test that with user input later. But we can try it out and see, right? So we need an int for the value, right? So some number, right? Whatever how about for our size, right? For how large of a triangle then. So instead of CNA on size, then we'll get some value for size. So I can use my inside this. We can assign it the value of get value within range. Oh my goodness, is that what I called it? Get user input within range. Get user input within range. So 0, or really probably 1, right, is the lowest I want to go. And up to what? Probably 100 is fine here. Right? So how large of a triangle? We'll get that value between 1 and 100. It'll be very exciting. So if I enter a number that's too big, it's invalid, try again. 0, invalid, try again. Right? So we can move our validation loops out into functions here. And then the cool thing is they work with different values, right? So not only is my code has a nice little name to what's happening here, but it's reusable with different values here. So I can use the same thing as the values 1 to 10, the values 1 to 100, for 1,000 to 2,000, right? Whatever ranges I want to give it here, the code is identical. So the next thing we're able to do is we're able to look at our code and say, oh, this is slightly different than what I did over here, but the only thing that's different is a variable. If the only thing that's different between two different blocks of code is a variable, there's a light bulb that can go off in your head and say, oh, that could be a function, and the thing that's different could be the argument for the function, the variable. Right? That's the only thing that changes here. So we can further reduce our amount of repeated code here by using functions that take variables. There's what's different here. Sure, the upper and lower bound. If you wanted to do some sort of string input here for the menu, that one gets to be a little trickier here. We don't know how arrays work yet, but you could give it a bunch of strings here. We could validate any of those strings. I haven't done arrays yet, though. That's a bummer. Oh, here, okay, so let's get a character input here. So we'll get character from user from valid string. And we can have a string for the prompt here, and then we can have a string for valid characters. Right? Remember, a string is just a bunch of characters here. So we can check all the different characters within them. Right? We looked at all the different string indexes, string index 0, 1, 2, 3, we did that one, right? Okay, cool. So if you give me the prompt here, I don't even need to see out anything initially here. I can see out that prompt that you give me, and probably an end line here, right? Most people don't add end lines to their prompts here. And then we get a char for the input here, and then we can see in on that input. And now we need to check to see if that input was valid. Right? Was it in the list here? Did we have, we didn't find an easy shortcut for that yet, did we? We have to loop through? I think we have to loop through. Okay, that's obnoxious, but that's okay. We can do that. So we can have a Boolean for is the input in valid characters, right? And we'll start that off as false until we know otherwise. All right, so actually let's ask them first here then. So we'll start this off as false here, and we can say while I is the input in the valid characters, while it's not in the valid characters, bless you.
Thank you.
So I want my loop to run. Here, I guess we could do a do loop too, but again, I hate do loops. We'll get the input. Right, we did the prompt. We know the loop's going to run. We'll get their input. And now I can go through and check for every character. Right, so for char character in my valid input characters, if my character, bless you,
Thank you.
is equal to the input. Oops, no, not a quote here. If it's equal to the input, then we can set this to true. Right, we found a match. Right, I'm going to look through every character, find a match. Now at this point, maybe you might like your keywords. Remember we found that fancy break keyword that will stop your for loop here? Sure, I dislike breaks here, but that's going to slightly speed this up. Like if my list of valid characters was 10,000 characters long, we don't have 10,000 characters right now, but if we had like all the Unicode ones, right, that might take a little while. And we've saved a bunch of checks here when we know it's already true. So maybe it's nice to break that loop here. This will break the for loop that it's in, not the while loop here. But then my while loop comes and says, oh, if it's not in the list of valid characters, ask them again, right? And maybe we have to repeat the prompt here. Look at that, we can repeat the prompt. Here's the prompt, here it is here. Go for it. Again, big and ugly, but now we've put a nice name to what's happening. You can tell it, hey, here's the prompt I'm asking for. Enter the the letters something or other here. Here's your valid options here, or Y for yes, N for no, right? And I only want to get back a Y or an N, right? Do you want to play again? Y or N? Sure. We got some options. So, well, maybe we want to, should we lowercase their input as well? And eventually then we need to return the input. Right? I guess we'll probably put that as lower, right? Input, no, input, oh goodness, now I have to declare it out here, sorry. It was invalid because I declared it inside the while loop, right? The scope of it was only inside the while loop, so it doesn't exist down here. So if we declare it outside the while loop, then it exists outside the while loop, and I can return it when we're done. All right, so should we try it? So get some characters. So a char for, I don't know, play again is a get character from user from valid string. Goodness. Do you want to play again? Is my prompt here with a Y or an N? And then my list of valid characters are just YN, right? So I give it two different arguments, right? The string is the prompt here. I could output it myself here, but this was a little bit easier because I want to be able to repeat that prompt here. If they did it wrong, I want to keep repeating it. Eventually, I'll get back a Y or an N. Right? The only way this comes back is if they give me one of these two valid values here. You want to play again? Oh, I gave it too many inputs, sorry. A, B, C, D, E, F, G. Right? If you're only taking a character, it gets one at a time. So it got all four inputs there. When we say no, eventually it will stop here, and life is good. So we got lots of cool capabilities and cool things we can do with functions. Now, are we solving problems we haven't been able to solve before? No. Can't really do anything new, but we can organize our code nicely. Right? We can put a nice name to what's happening here. Um, and ideally, your main function is actually pretty easy to read, and there's not a lot of code in there, right? You want most of your code to be off in functions so that someone can come look at main and be like, oh, it's getting a character. Oh, it's finding intercepts. Oh, it's doing some random number thing. Oh, it's getting some user input, right? Oh, it's going to print a triangle. You can quickly scan through the names of the functions to get a feel for what your code is doing. And then if you want to know, oh, what is that actually doing here? Then I can go up to that function and go read that particular piece here. But that way, as I'm reading through main, I can get essentially a feel for what is happening without knowing all the details right away. So it breaks it down into smaller pieces, lets us organize it, make it look a little cleaner here. Um, Again, depending on who you talk to, people have all sorts of fun rules and things with their functions. And some people say they should fit on a single screen. That's probably a good rule of thumb, but again, that's more of the art side of things here is how you like to format it here. And I'm zoomed in a little bit, so I feel a little bad that that's kind of big, but if you're using like a normal size font here, um, like I had plenty of room to fit more characters here, right? But I'm zoomed in a decent amount here. So that might be too much. Is that still viewable? Okay. So we put a nice name to it here. It's reducing repeated code, which is really nice. We always want to not have the same code twice because we don't want to feel bad about ourselves, right? And then it gives you the opportunity to not have repeated code if the only thing different is a variable. Right? We've done lots of user input within ranges and things like that. We've done lots of silly testing here. So in this case, sure, the only thing that's different was the ranges. This one's easy to check here. If I'm testing some sort of user input, was this valid input? Sure, that's easy to check, right? And we can essentially use this function anytime we need to get input now. You've got it done, ready to go, just copy paste, right? We haven't figured out how to get it from another project. That's why the testing was going to be obnoxious here. Getting code from one project to another project is obnoxious until we get to classes. They're made for that sort of thing. So anytime you want to use this function, go for it. Copy paste it in, you've got the code done. You should feel good. That should do what it's supposed to do. We've tested it out. We'll feel pretty good about it here. Let's see. So other common errors. Yeah, you can go through the rest of those ones. It's fine. Missing returns is big. We did passing by reference. That's a big one. I don't want to go to these other. We'll save these other ones for later. We got lots of time to talk about functions here. Um, Yeah, I think we're doing pretty good. Is it? You want to stop a little bit early? We got a little bit of time for functions. Okay, we stop a little bit early. Take the time. Make sure you're working on project one. Again, if you want to use functions, go for it. You don't have to. Um, totally up to you. But when I solve it, I'll solve it with functions because I think they're fun. That sort of thing here. So um, we got till next week for this one here. So on October 6th, we won't have tons of time for functions because we'll do the project solution and talk about our next project, which will be using functions. Hey, you guessed it. Good job. Um, Can we go from there? Okay. Awesome. Thanks, everybody. Take care. I will see you Wednesday then. Have fun at lab.